So we're looking at polynomial functions today, and we have already been dealing with polynomials. A linear function is a polynomial, a quadratic is a polynomial, and now we're going to be looking at cubics and quartics. So what is a polynomial? Well, basically it will take this particular form. And when we decide what sort of polynomial we have, remember poly means many, we look at the highest power of the x. So if we were looking at a linear, y equal to x plus 1, okay, the highest power of x there is 1. If we were looking at a quadratic, y equal to x squared plus 2, the highest power of x there is 2. Even if I had x squared plus 2x plus 3, which is still a quadratic, the highest power of x is 2, because this power of x is 1. Okay, so that is a polynomial. So let's have a look at these polynomials down here. And we're told that in this first example that p of x is equal to x to the power of 4 minus 3x cubed plus 2. So remember, p of x, a polynomial in terms of x. So for the first one here, we are looking for p of 1. That's saying wherever we have got x, we will put 1. So it's 1 to the power of 4 minus 3 times 1 cubed plus 2. 1 to the power of 4 is 1. 1 cubed is 1 times by minus 3 is minus 3 plus 2. 1 minus 3 is minus 2. Minus 2 plus 2 is equal to 0. What about the next one? We're substituting in p of minus 1. So we're substituting in x equal to negative 1. So be careful here. Negative 1 to the power of 4 minus 3 times negative 1 to the power of 3 plus 2. Now a negative number raised to an even power will always be positive. So that's positive 1. Negative 1 to the power of 3 is a negative 1. Times by negative 3 gives you positive 3 plus 2. And of course 1 plus 3 is 4 plus 2 is equal to 6. All right, what about the next one? Part C, we're looking for p of 2. And of course we could do this in our calculator. We could define the function as x to the power of 4 minus 3x cubed plus 2 like we did when we were doing quadratics. Okay, we'll go through that in class when we meet on the chat. So p to the power of 2 is equal to 2 to the power of 4 minus 3 times 2 to the power of 3 plus 2. Now 2 to the power of 4 is 16. 2 cubed is 8 times minus 3 would be minus 24 plus 2. 16 take away 24 is negative 8. Negative 8 plus 2 is equal to negative 6. And the last one here, we're looking for p of minus 2. Again, substituting in, so you get negative 2 to the power of 4 minus 3 times negative 2 to the power of 3 plus 2. Negative 2 to the power of 4 is also positive 16. Remember, we have an even power, so we'll always end up with a positive number. Minus 2 to the power of 3 is negative 8. Negative 8 times negative 3 is positive 24 and plus 2. And our final answer there is 42. Okay, in this example, we're told p of x is equal to x cubed minus 6x plus 3, and q of x is equal to x squared minus 3x plus 1. Both of them are polynomials. One of them is a cubic because its highest power is 3. This one, q of x, is a quadratic. Its highest power is 2. Now in part A here, we're asked to add them together. So p of x plus q of x. So I've got x cubed minus 6x plus 3 plus x squared minus 3x plus 1. Let's group together any like terms there. There are no other x cubes, so that stays by itself. There are negative 6x and minus 3x. Okay, there's an x squared by itself. And there are constants. So let's do all of them together. So we've got the x cubed, the next bit is plus x squared. Okay, we've got minus 6x minus 3x is minus 9x. And we've got 3 plus 1, which is equal to 4. No more like terms. So that is completely done. The next one is p of x minus q of x. Now we need to be careful here with that minus sign. So let's write it out again. P of x is x to the power of 3 minus 6x plus 3. Take away. We're taking away the whole lot here. So take away x squared minus 3x plus 1. All right, that makes a difference because that's going to make everything inside that bracket negative. So I'm going to expand that bracket out first before I start grouping together my like terms. So x cubed minus 6x plus 3. Okay, minus times that is minus x squared. Minus times that gives me plus 3x. And minus times that gives me minus 1. All right, grouping together like terms now. X cubed, nothing to group with that. Nothing to group with the x minus x squared now, so minus x squared. Looking at my x's next, minus 6x plus 3x gives me minus 3x. And 3 take away 1 is positive 2. Notice how I'm writing the polynomial in decreasing order of powers. So my powers decrease. I've got 3, I've got 2, I've got 1, and really that's x to the power of 0, even though we don't write it, because anything to the power of 0 is 1. So always write your polynomial in decreasing powers. All right, let's look at the last one here. And this one is asking us to multiply. So we have x cubed minus 6x plus 3. That is times by q of x, which is x squared minus 3x plus 1. Now remember, when we multiply indices, we actually add the powers. So we've got x cubed times x squared gives you x to the power of 5. And then we have x cubed times minus 3x, so it'd be minus 3x to the power of 4. And then we've got that times that, which is just x cubed. That's the first bit. The second bit, all right, we're now taking minus 6x and multiplying the bracket again. So it's that times that, which is minus 6x to the power of 3. That times that. Minus times minus is positive. 6 times 3 is 18. X times x, x squared. And then this last one, which is 1 times minus 6, which is minus 6. And very last one is now taking the 3 and multiplying that by everything. So 3 times x squared is plus 3x squared. 3 times minus 3x is minus 9x. 3 times positive 1 is positive 3. Okay, obviously now our last step is to group together any like terms. So is there anything to match up with the x to the power of 5? No. Is there anything to match up with x to the power of 4? No. So minus 3x to the power of 4. So matching together the x cubes, we get 1x cubed minus 6x cubed. That becomes minus 5x cubed. And the x squareds, we've got 18x squared and 3x squared. So that's plus 21x squared. Minus 6x minus 9x minus 15x. So just grouping together all like terms. And that is our final answer. All right, so this last example is an extremely interesting one, and this is where we equate coefficients. So what we like to do is compare one polynomial to another. If you have a look in the top example there, you can see for p of x, in front of the x cubed is a 4, and in front of the x cubed is an a in q of x. So therefore a must be equal to 4 because we're told that p of x is equal to q of x. All right, the other bit there, what's in front of the x squared in p of x? It is 5. What's in front of the x squared for q of x? It is b. Again, because those two equations equal each other, then b must be equal to 5. All right, and the last one there, you can see that c of x, this is minus 1 in front of the x, and that's c of x, so c must be equal to minus 1. And here our constant is 3, our constant is d, so d is equal to 3. So let's put that together in an example over here. We're told that p of x is equal to that function, and it can be written in that format where b, c and r are real numbers. Find the values of b, c and r. So what I really want to do at this point is get them in the same format. I think the easiest thing to do would be to expand that out and try get it in polynomial format. So let's try expanding that. You get x minus 2, and you've got x squared plus b of x plus c plus r. Now be careful with your expanding. So it's going to be x times that times that times that. And so you get x cubed plus b of x squared plus c of x. Okay, and now we're going to expand using the minus 2. So minus 2 times that, and times that. So it's minus 2x squared minus 2bx minus 2c. And don't forget and we'll do that in a different colour because that was separate, plus r. Okay, now what I will do is write that so that I've got all my x cubes together, x squareds together, x together, and constant. So it's x cubed, all right, plus bx squared minus 2x squared. So they're not the terms that have got x squared in them. Now I'm going to look at the terms that have got x. So plus c of x minus 2bx. All right, what else do I have? No other x's. So the last thing then is whatever is left over, which is minus 2c plus r. So can't match up anything with the x cubes. I'm going to leave that like that. Now I'm going to take x squared out here. What's left inside the bracket once I take x squared out? I get b minus 2. Okay, I'm going to take x out of the next lot. All right, so that was x squared. And I'm going to take x out and I get c minus 2b and then minus 2c plus r. So let's start equating our coefficients. We know that p of x is equal to that, and we've just worked out what this is in this statement here. So what's in front of the x cubed here? It's a 1 and it's a 1. So that's, we would expect that. What's in front of the x squared for p of x? It's 3. And what's in front of the x squared for this one? It is b minus 2. So we can say that 3 is equal to b minus 2. Well, it's easy enough to find what b is equal to. Bring the 2 across by adding and you get b is equal to 5. All right, let's have a look then at the next one. All right. So we now know that what's in front of the x for this one, c minus 2b, and in front of the x here is 2. So 2 is equal to c minus 2b. Well, we've just worked out what b is. B is equal to 5. So minus 2 times 5. 2 times 5 is 10. So c minus 10. And of course, bring the 10 across and you get c is equal to 12. All right, so now the last bit that we're looking at here, this bit here doesn't have an x or an x squared in front of it. That's actually our constant. And what is our constant in p of x? It is 1. So 1 is equal to minus 2c plus r. Again, we've found what c is. So 1 is equal to minus 2 times 12 plus r. 1 is equal to minus 24 plus r. Bring the 24 across and you get 25. So r is equal to 25. We have equated the coefficients in our two polynomials, and by doing that we let them equal each other and then we can solve them as equations.